All right, ladies and gentlemen, in this video, I'm going to go over every problem on the review sheet for your Unit 2 exam. As a reminder, this is going to be a long video, all right? But you're not required to watch the entire thing. I encourage you all to fast forward, find the problems that you need help with, and watch those sections of the video, all right? If you do your work and you check the answer key that I post and you say, oh, I understand how to do this, there's no need for you to watch that part of the video, okay? Feel free to watch the entire thing. Feel free to watch parts of it. Feel free to rewatch and watch as many times as you want. As always, that does not mean that you're not allowed to ask me questions, all right? You are more than welcome to ask me questions. I'm more than happy to help you, but this is just in case you're working and it's late at night or it's not during the school hours and you can't reach me, okay? So, ladies and gentlemen, let's get started. Number 1, which of the following points is a solution to the system shown below? So we have two lines where we have two equations. If we graph them, they're going to be lines. Let's do this just using the Desmos graphing calculator. Since this is Since this is a multiple choice question, you don't need to show your work, and we're going to be doing plenty of algebraic solutions, we're going to be doing plenty of solving systems of equations algebraically later, so let's just practice using the Desmos for now. So the first equation is y equals x plus 7. So I'm going to go to Desmos and I'm going to type in y equals x plus 7. In my next cell, I'm going to type the next equation, y equals 11 minus x. Our equation, or our graphs, intercept at the point 2, 9. So our solution for number 1 is 2, 9. And how did I get that? Well, I graphed these in Desmos. So you're going to graph in the Desmos graphing calculator, and you're going to find the intersection. And then you're done. No work to be shown there, unless you want to do it substitution. But I'm going to show you examples of that later, okay? So number 2, which of the following is the x-coordinate of the solution to the system shown below? So again, it's multiple choice. We don't need to show any work. Let's just type these right in. Y equals 4x plus 7. And then x plus y equals negative 3. So the solution is negative 2 comma negative 1. So our x is negative 2. So it's choice 4. All right. So we have choice 4, negative 2. So again, I'm going to do the same thing. I'm going to find the intersection. I'm going to graph in Desmos. I'm going to be lazy and just do that. We're going to graph in Desmos graphing calculator, and we're going to find the intersection. All right? Easy peasy when we're multiple choice. Number 3, the linear equation y equals negative 2x plus 6 is shown graphed below. If it creates a system with the linear equation y equals x plus 3, which of the following would be the y-coordinate of the solution? So here I'm asking you to graph it on paper on the exam. You're not going to ever have to graph on paper since you're not in person and I can't give you a handout, but just make sure you know how to graph a line, all right? So they gave us this graph. We don't need to graph it. But we do need to graph y equals x plus 3, all right? Recall that when we are graphing a line in the form y equals mx plus b form, our slope is m and our y-intercept is b. So here, we don't have any number written in front of the x, so our slope is 1. And our y-intercept is 3. So we're going to start at 3, so we're going to count on the y-axis up 1, 2, 3, put a dot. And then we're going to go up 1, right 1. So we have 1 over 1, so we're going to go up 1, right 1. So up 1, right 1, 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 and then down 1, left 1. And then you don't need to draw all of them, but then you're going to connect your points. Okay? When you connect your points to find the solution of our system, it's where our graphs intercept. We saw that on the Desmos example. So our graphs intercept right here. So the coordinates are 1, 1, 2, 3, 4, So it's asking us for the y coordinate. So if the interception point is 1, 4, our y is 4. All right? Give me a second. I have to calibrate the smartboard. All right? So that's number 3, graphing systems of equations and finding the solution. The solution is where the graphs intersect or cross. All right? Number 4. Another multiple choice question. So I'm not even going to do any work algebraically. I'm just going to go right to Desmos again, and I'm going to type in my equations. 3x minus 2y equals negative 19. And then in the second one, I'm going to type in my second equation. 2x plus 2y equals negative 6. So they intercept at the point negative 5, comma 2. So my x coordinate is negative 5. All right? Number 1. So I'm going to do the same thing I did in here. I'm going to be lazy though. I'm going to copy and paste this. So I'm literally just going to type these in, Desmos, and find the intersection point. All right? So again, this doesn't mean that you don't know that you don't need to be able to solve them algebraically. We're going to be doing that in a couple examples, okay? But for multiple choice questions, you don't need to show your work. So now number 5, is the point 513 a solution to the system shown below? Explain graphically or algebraically. So I'm going to show you both, graphically and algebraically. And you don't need to show both. It says or, but I'm going to show you both, and then you can decide which one you like better. So we know that when we plot a point, it's always in the form x comma y. So we need to test in this equation if x equals 5 and y equals 13 will give us two true equations when we plug them in. So let's take our first equation, y equals 4x minus 7. When I plug in 13 for y and 5 for x, let's see what we get. So we're going to get 5 times 4 gives me 20, and 20 minus 7 indeed gives us 13. So we know that this point lies on this line, but we're not finished yet. We also have to check if that point lies on my other line as well. So we have 2x plus y equals 23. So I'm going to do the same thing. Plug 5 in for x and 13 in for y. All right, 5 times 2 gives us 10, and 10 plus 13 gives us 23. So now it's asking us to explain. So I need to explain. So yes, because when we plug in, and you don't have to write exactly this, when we plug in x equals 5 and y equals 13 for both equations, they are both true equations, or they satisfy both equations. So you could write this, you could write everything that I just wrote, or you can see if they intercept graphically. So let's see what happens when I graph them. So I have y equals 4x minus 7, and then I have 2x plus y equals 23, and then my graphs intercept at the point 5, 13. So you can write all of this, or you could write yes, because when graphed, the lines intercept at 5, 13. So you do not need to write both. Okay? Write one or the other. Alright? Number 6. Solve the following systems of equation using the method of substitution. Alright. So we are going to use the substitution method. we have one variable by itself. We know that y is equal to negative 2x minus 10. So what we're going to do is we're going to take negative 2x minus 10 and plug that in for y. So I have 2x plus 5y equals 6. Instead of writing my y, I'm going to write the whole negative 2x minus 10 in for y. I'm going to substitute it in. Make sure you put it in parentheses because we are plugging the entire thing in for y. So we are multiplying the entire thing by 5. Okay? Now we're just going to solve for x. So we have 2x plus, use the distributive property. I'm sorry, this should be minus, right? Because 5 times negative 2 gives us minus 10x. 5 times negative 10 gives us minus 50. And now we just solve for x. Okay? So we're going to combine like terms. 2x minus 8x gives us, 2x minus 10x gives me minus 8x. Alright? And now we just solve this regular old two-step equation that we know and love. So we're going to add 50 to both sides. We get negative 8x equals 56. And then after I divide both sides by negative 8, I get x equals negative 7. So now I'm not finished yet because remember, when we solve a system of equations, we need two numbers. We need an x and we need a y. So now to get our y, I'm going to take my top equation. I'm going to take my negative 7, plug it in for x. So I have y equals negative 2 times negative 7 minus 10. Negative 7 times 2 gives us positive 14. And 14 minus 10 gives us 4. So that means if I was to graph these lines, they would intercept at the point negative 7, 4. So I can check this on my Desmos graphing calculator, as always. So I'm going to type in both equations. Y equals negative 2x minus 10, and then 2x plus 5y equals 6. And then if I see where my graphs intercept, they intercept at the point negative 7, 4. So I can always check these using my Desmos graphing calculator. All right? All right? So I just paused so I could put this an image of the graph up for the answer key, all right? So that's number 6, the substitution method. Okay? Number 7, solve using the method of elimination. So, elimination method. Elimination, what we need to do is we're going to add both of our equations together. Okay? When we do that, one of our variables should cancel. Now let's see what happens when we do that here. 3x's go away. Why? Because negative 3x and 3x cancel. It's 0. So 10y plus 7y gives me 17y. And then 17 plus 17 gives me 34. So I have 17y equals 34. I'm going to divide both sides by 17. And I get y equals 2. Okay, as always, I'm not done yet. I need an x and a y. So I'm going to take either the top or the bottom. It doesn't matter. I'm going to take the bottom because there's less negatives involved. So I think it's going to be a little bit easier. I'm going to take my y and take my 2, plug it in for y. So I have 3x plus 7 times 2 equals 17. Now I'm just going to solve for x. So I have 3x plus 14 equals 17. I subtract 14 on both sides. They go away here. I have 3x equals 3. And then after I divide both sides by 3, I get x equals 1. So that means that if I was to graph these lines, they would intercept at the point 1, 2. All right? So I'm not going to show you on the Desmos graphing calculator again, just to save some time. Okay? Let's just move on to the next one. All right, so the reason I paused there is just so I can put it up for the answer key. So you can check in on Desmos. If you graph them here, you will indeed get the same answer, 1, 2. All right, so let's take a look at number 8. Solve the following systems of equations graphically. Label your equations. All right, so we have two equations here. We have y equals negative 1 half x plus 2, and then we have 2y minus 5x equals negative 8. If we try to graph this guy the way it's written, we're going to run into an issue because y is not by itself. So what we have to do is get y by itself. So we have to add 5x to both sides. Okay, these are going to go away. going to be left with 2y equals 5x minus 8. And then we're going to divide each term in my equation by 2. Okay? That's going to leave us with y equals 5 over 2x minus 4. Okay? So we have, remember, y equals mx plus b, a slope of positive 5 over 2, and a y-intercept of negative 4. So whenever we have a positive slope, we're going to go up and right, and we're going to start at the y-intercept of negative 4. So we're going to go 1, 2, 3, 4 down, put a dot, and then count up 5, right 2. 1, 2, 3, 4, 5, 1, 2, put a dot. 1, 2, 3, 4, 5, 1, 2, put a dot, and then that's it. That's all I can put there on my axes. Okay? Connect our dots. And again, you're not going to be asked to do this on paper on the exam, but you are going to have to do it on Desmos, so make sure you know how to do it. Okay? Now it asks us to label it, so to label it, we're just going to put our equation. Okay? And then here, this equation is already by itself, so we have a slope of negative 1 over 2, and a y-intercept of positive 2. So we're going to go down and right. Okay? Always go right, and then determine if you're going to go up or down by the positive or negative sign. So we're going to start at positive 2 y-intercept. We're going to go down 1, right 2, 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 or up and left. You don't have to plot all the points, but just so you get the idea. Then we're going to connect our points with a line. And label it. Okay? Remember, the solution is where our graphs intersect. So right here. 1, 2, comma 1. Okay? So ladies and gentlemen, that's number 8. All right. Number 9. Solve the following system by method of elimination. So we have 2x plus 5y equals 5, and 3x plus 2y equals negative 9. So if I was to add these guys together, remember elimination, we always add the two equations together. Okay, if I was to add these two together, and don't write this down, let's see what we would get. 5x plus 7y equals negative 4. That does not help us at all. We need to get it so that one of our variables is eliminated when we add them together. So what I'm going to do is I need to figure out, okay, what can I do here to make it so that one of our variables is eliminated when I add them together? So I need to multiply one or both of these equations by a number. So remember our little trick. We can look at our first variable, x, and multiply each of these equations by the coefficient of whatever the other one is. So I'm going to multiply the top by 3 and the bottom by 2, and then I need to negate one of them. Okay? So let's just negate the top just so, just for consistency's sake. So multiply the top by this number, and multiply the bottom by this number, and then negate one of them. So now let's see what happens when we do that. Okay, remember to distribute, multiply everything in the equation by that number. So we're going to get negative 6x minus 15y equals negative 15 on the top. And then on the bottom, when I multiply everything by positive 2, I'm going to get positive 6x plus 4y equals negative 18. Okay, now when I add these two together, look at that. My 6x's go away. I'm left with negative 11y equals negative 15 minus 18 gives me negative 33. And then when I divide both sides by negative 11, I get y equals positive 3. Okay, so I'm not done yet though. I need to solve for x. So let's take our top equation. 2x plus 5y equals 5. Take my 3, plug it in for y. So I have 2x plus 5 times 3 equals 5. 2x plus 15 equals 5. Okay, subtract 15 on both sides. I get 2x equals negative 10. and then after I divide both sides by 2, I should get x equals negative 5. So that means if I was to plot these or graph these lines, they would intercept at the point negative 5, comma 3. Okay? And again, you can check on Desmos. Let's see how we can check on Desmos. All right? On the top, we're going to plug in the first equation, original equation, 2x plus 5y equals 5. And then in the bottom, we're going to plug in our original second equation, 3x plus 2y equals negative 9. And look at that, they intercept at the point negative 5, comma 3. All right, so the reason I paused there is just so I could graph it and then put the answer key up. Put the image of the graph up. It's the answer key. All right, let's take a look at 10. Solve the following by method of substitution. So here we have two things that are equal to y. So since they're both equal to y, that means they have to be equal to each other. So I'm going to set 2x equal to 7x minus 15. The reason I can do that is because, again, they're both equal to y. So since they're both equal to y, they have to both be equal to each other. Okay, so now I'm just going to solve for x. So subtract 7x, get negative 5x equals negative 15. Be careful, you have to bring down that negative. All right, and that minus sign to be negative. And then after we divide both sides by negative 5, x equals positive 3. Okay, now to solve for y, I need to take one of our equations. Let's take the top, because it's going to be a lot simpler. And just plug in my 3 for x. So I get y equals 6. So if I was to graph the lines, they would intercept at the point 3, comma 6. Let's check on Desmos. If you don't believe me, let's check on Desmos. We're going to plug in the top equation, y equals 2x. And then the bottom, we're going to type in y equals positive 7, 7x minus 15, and 3, comma 6. All right. Number 11. At a local movie theater. So now this is a word problem. At a local movie theater, soda costs $4.50 and bags of popcorn cost $1.50. If Kirk buys 3 times as many bags of popcorn if Kirk buys 3 times as many bags of popcorn as sodas and pays a total of $36, answer the following question. So he's paying a total of $36 and he's spending $4.50 on soda and $1.50 on popcorn. So what we have to do is we have to write 2 let statements, but here we don't have to because they gave us variables. So if S is the number of sodas bought and P is the number of bags of popcorn, write a system of equations that models the scenario. I'm going to explain how your system models this problem. All right? We don't need to explain. Just write the system. Okay? So we know that each soda costs $4.50. So $4.50 times S is going to be the amount of money that he spends just on soda. If he buys S sodas, he's going to spend $4.50 times the number of soda that he buys. Now, if he spends $1.50 on each individual bag of popcorn, $1.50 times P is going to be the amount of money he spends in total just on popcorn. When we add them together, that's going to equal the total amount that he spends, which is $36. So I'm going to set this whole thing equal to 36. They're both equal to the total amount of money that he spends. All right? So now the second equation, we have, he buys 3 times as many bags of popcorn as sodas. All right? So he's going to buy 3 times as many bags of popcorn as sodas. So, give me a second here. All right, I just wanted to check one thing. So that means that the number of bags of popcorn P is 3 times the number of sodas that he bought. So P is going to equal 3S. Now, determine how many of each that Kirk bought. Do this by using Desmos graphing calculator. So we can do the substitution method here if we want, but I'm not going to require you to do that because we have done plenty of algebraic solutions to systems. So what we're going to do is we're going to type this equation into Desmos. Now be careful, we have S and P here. So into Desmos, we can't type S and P. So we need to figure out one variable is going to be X and one variable is going to be Y in Desmos. So let's make SX and let's make PY. Okay, so in Desmos, we're going to plug in 4.5x instead of S, because if we type in S, we're going to have an issue. Okay, so 4.5x plus 1.5y equals 36. And then in the second one, we're going to write y equals 3x. And now they intercept at the point 4, comma 12. Now, what does this mean? Well, if they intercept at the point 4, comma 12, we said that x was S and y was P in our graph. So that means that he bought 4 sodas, right? Because our S was represented by X in our graph. So if we intercepted, if we looked at where the graph's intercepted, they intercepted where our X was 4 and our Y was 12. So that means that he bought 4 sodas and 12 popcorns. So he was very hungry that day. Okay, so I'm going to pause it here, and I'm going to just paste the Desmos graph. All right, guys, one more and then we're done, all right? So Jody is supplying his food truck for the week. He buys 32 pounds of pork and 50 pounds of chicken for a total of 185. So then realizes he did not purchase enough of either and returns to buy 8 more pounds of pork and 20 more pounds of chicken for a total of 65.60. So we have 2 totals. Our first total is 85 and our second total is 65. Determine the unit price, meaning the price for 1 pound of pork, 1 pound of chicken, for each. Okay, so let's let X equal our pork, the unit cost of pork. So cost of 1 pound of pork, and then let's let Y equal the cost of 1 pound of chicken. All right, so now let's see what our equation is. So our first total is 185. So we know that since our first total is 185, one of our equations has to equal 185. And then our other total is 65.60. So our other equation has to equal 65.60. Let's break this down. Okay? He buys 32 pounds of pork and 50 pounds of chicken. 32 pounds of pork, 50 pounds of chicken. So 32 times P, or 32 times X, is going to give us the amount of money that he spends just on pork if he buys 32 pounds. 50 pounds of chicken, 50Y, is going to give us the cost that he spends just on chicken if he buys if he buys 50 pounds of chicken at Y dollars. Okay? Now the next, he goes back, he buys 28, let me erase this. This is a little messy here. Oh, I can't erase that highlighter. All right, give me a second. All right, sorry about that. I just wanted to erase the highlighter. Now, he goes back, he buys 8, whoops. He goes back, he buys 8 pounds of pork, 20 pounds of chicken for this total. So now, 8 pounds of pork, to represent the amount of money he spends on that, we're going to write 8x. Okay, so that 8x just means the amount of money he spends on pork if it's costing him X dollars. He's going back and he's buying 20 pounds of chicken, so that's going to be represented by 20y. Okay, so now we're just going to type this 2 equations into Desmos and see what we get. So we have 32x plus 50y, and you don't have to use x and y. I just did so that we would have consistency with our Desmos graph, okay? So we have 8x plus 20y equals 65.6. And now let's see where our graphs intercept. 1.75, comma 2.58. So now that means that x equals 1.75 and y equals 2.58, which means the cost of the chicken, or the unit cost, meaning the cost of 1 pound of chicken, unit cost of the chicken is $1.75, $1.75, and the pork is $2.58. Okay? So when I'm asking you to solve a word problem with the system, I'll always have you just do it on Desmos to save you some time. All right? So I'm just going to put this graph here. Ladies and gentlemen, I know this was a long video. Again, I hope this helped. Please do not hesitate to reach out with any questions. This video does not mean that you can't ask me questions. I'm more than happy to help. All right? So good luck with your studying. And this is a really good comprehensive review for the exam. Okay? So have a good day.